All right, 11.4. So we're going to have rational expressions and how to simplify them, okay? So really to start with, a rational number, right, is just a number that can be written as a quotient, right? So it's a fancy way of saying a fraction. So like 1/2, 6/5. All whole numbers are over 1, so 4/1, okay? These are examples of rational numbers. They're just fractions, okay? When you have a rational expression, both the numerator and the denominator are going to be rational expressions, okay? And remember that a rational expression is going to contain variables now. So for example, 2/x minus 3, or 3x over x squared minus 2, or x plus 1 over 3x minus 4. Okay, these are all rational expressions. They have a numerator and a denominator, and they contain rational expressions. So you have variables now. Okay. A rational expression is undefined when the denominator is 0. Okay. So for example, the first one, right? The denominator is x minus 3. So when that equals 0, the whole thing is undefined because you can't divide by 0. So when x equals 3, this first rational expression is undefined because you cannot divide by 0. Okay? All right. When it comes to simplifying, right, the idea is kind of like a fraction. So when you try to simplify a fraction, you look to see if the numerator and the denominator have common factors. And if they do, you divide them out, okay? So the rule says that if your expression or fraction, right, is a times c over b times c, then we can write that as a product. They both have a c in common, so we can simplify that by dividing them both by c, and we get a over b. Right, so when it's a fraction like 12/21, we can rewrite 12 as 3 times 4, and we can rewrite 21 as 3 times 7. Well, they both are being multiplied by 3, so if we divide them both by 3, then we can simplify that to 4/7. Okay, the same is going to happen with your rational expressions. Okay, so you're going to write them as a product, and then if they have a common factor, not a common term, right? That's the biggest mistake I see is people try to cancel out terms, and you can't. Okay, it has to be a factor, meaning it has to be part of a product. Then you can simplify if they have a common factor, right? So if I have 5 times the quantity 3 minus x over 5 times x, or just 5x, okay, because that's usually how we write it. I'm writing these as a product, okay? We have 5 times something over 5 times something, right? Because it's 5 times the quantity 3 minus x over 5 times x. Right, here's our product. Okay, then the common factor is they both are being multiplied by 5. So I can cancel out a 5 because it's common to both, and then I end up with 3 minus x over x. You cannot cancel out the x's, okay? It is a term in the first one. It's not a factor. It's not being written as something times x, okay? So the x's do not cancel. So then that's completely simplified, okay? All right, then if I have something like 2x squared over x times x plus 5, okay? Writing it as a product, right? In the numerator, I have 2 times x times x. And then in the denominator, I have x times x plus 5, because x squared is x times x, okay? So then I see that they both have this x as a factor because it's part of a product. So I can cancel that out and I can simplify it to 2 times x over x plus 5. Again, you cannot cancel out the x's. They are not a factor in the denominator. Okay, it has to be a factor. So the first thing you do is you want to factor both numerator and denominator and see what's common to both. Okay, so let's look at the next example. Right, so we have 15x over 5 minus 10x. Okay, so if we think back to factoring, can you factor the numerator? Can you write it as a product? And we can. That would be 3 times 5 times x. And then in the denominator, we have 5 minus 10x. It's a binomial, so it's 2 terms. Do the 2 terms have anything in common? And they do. So if I factor out of 5, right? It's like dividing those 2 terms by 5, so I get 1 minus 2x. Then I look and see, okay, there's a 5 in the numerator, a 5 in the denominator as a product, so they can cancel. And I can simplify to 3x over 1 minus 2x. Cannot cancel those x's. They are not factors of both the numerator and the denominator. So it's completely simplified. Okay, then we have x squared plus 6x plus 9 over 9 minus x squared. We want to try to simplify that. Okay, so we're going to factor the numerator and factor the denominator. We just spent a whole chapter factoring quadratics. Okay, so the first one, it's a coefficient of 1, or they're factors of 9 that add up to 3, or add up to 6, and there are, right? Factors of 9 would be 3 and 3, so we get x plus 3 times x plus 3. Okay, then the denominator is a difference of 2 squared, so that's 3 squared minus x squared. So we're going to get 3 minus x times 3 plus x. Okay, and we look to see, do they have anything in common? And they do. These two are the same because x plus 3 and 3 plus x, they're both the same signs. So these are the same factors. Okay, so we get x plus 3 over 3 minus x. And that's completely simplified. These are not the same because it's a negative x in the denominator. Okay, and it's completely simplified. Right, so factor both numerator and denominator, cancel out any common factors. All right. Last part of 11.4 is where can this be useful? And it's something called geometric probability. Okay, probability is a whole course in and of itself, but really what it is it's measuring the likelihood that an event is going to happen, right? So if you think about tossing a coin, the probability of a heads versus a tails, right? What are the chances that you're going to get a head versus the tails, okay? So geometric probability, we're talking more about the area of objects. So if you've ever played like a carnival game where you had to toss a beanbag through a circle in a rectangular board, right? Your probability would be the area of those circles over the area of the whole entire board, okay? So if you have two regions where one is contained in the other, then the probability that, so region B is in region A. Okay, so here's region A and here's region B. So if you toss a ball or a beanbag, the probability of it going through B, okay, is going to be a capital P, and it's going to be the area of what you want over the total area, okay? So probability is always between 0 and 1. It's a likelihood that something's going to happen. So it's between 0% essentially and 100%. 0 meaning no, it won't happen. 100 meaning it's definitely going to happen. Okay? So to see how it works with numbers, we have a region that looks like this. Okay, so it's a rectangular region, and a triangle is divided into it. Okay, and then it's actually a square. So this length is x plus 3. Okay. And then, actually, let's see, we're going to label it here. And then this little piece here is going to be 2x minus 4. So we want to find the probability that if you toss a coin at this whole region, it's going to land in the triangle. Okay? So the probability is going to be the area of the triangle divided by the area of the square. Okay? So area of a rectangle or triangle is 1/2 base times height. And the area of a square is just a side squared. Okay? So when we look at the figure, okay, the rectangle, not the rectangle, the triangle, it's base times height. So the base is 2x minus 4, and the height is x plus 3. Okay, then the square, the sides are the same, so this is x plus 3, this is x plus 3. So the area of the square is x plus 3 times x plus 3. Okay, then we can simplify this. So when you notice, right, simplifying rational expressions, they both have an x plus 3, so I'm going to cancel that out. Then I can distribute the 1/2. So 1/2 times 2x is x. 1/2 times 4 is 2. So we get x minus 2 in the numerator divided by x plus 3 in the denominator. Okay, so that's the probability. And then if you have an x value, you plug it in. So the probability that it's going to land in the triangle versus anywhere else on the entire square. Okay? So that is our simplifying our rational expression.